Hey guys, welcome back. In this video, we will be setting up our database functionality. Now, in our previous video, we went through and we started implementing our repository pattern, our interfaces, and the repository classes to inherit from the interfaces. However, when we implemented the functions that would have been outlined in the interfaces, we did not go through setting up actual functionality in these functions. So we have the bool create function here, but it only throws an not implemented exception. And that's basically the case for every single one of them. So we're going to go through setting up one of the repositories, and we'll start with the leaf type repository. This is the first one that we set up. And then I'm going to pause and allow you to set up the others, and then we can go through it together. Now, our leaf type repository class, it's inheriting from iLeaf type repository, which if we take a look at that, it is also inheriting from the repository base, and it has its own function in that implementation, in that interface. So then we have about 6 functions from the repository base, and then we have an additional function from the iLeaf type repository. And so our inheriting class or repository class would have a total of 7 functions that need to be implemented. Now I'm going to start writing in functions in the same order that they would appear in the interface class. That's for no particular reason. It's just, in building up, if you're not so familiar with Entity Framework, I'm going to bring you through step by step and show you how you can use Entity Framework to interrogate the database. So we're going to start off with the iCollection find all. So the idea behind this function is that once this function is called relative to whichever repository and whichever class it's dealing with, whichever table it's dealing with, it should get back all the records in that table, right? So for context, if you wanted to show a grid of all the leaf types that are in the system, then you need to get all the leaf type records from the database. And so you need to find all, right? So in implementing that function, we go to find all, and it's right here. All right. And the expectation is that we're returning some form of collection of the data type, leaf type, which once again is just a class. And I can just hold on Control and click, and it will go to the actual implementation of the class, or definition of the class rather. And it will show us what it is. It's a database class or a data class, DB set class, however you want to put it. But the fact is it's a table in the database, and it's represented in our project as a class called leaf type. So I want a collection of records that look like this class, pretty much. So in this function, which is find all, I'm going to erase this throw new not implemented exception. And then I'm going to invoke my connection to the database. So from our previous video, we had set up that connection through this variable called DB. So I'm going to use _DB. And then I'm going to say dot. And then you would realize that you have quite a few functions available to you. But then more importantly, you'll start seeing that you actually have the tables made available to you. So you'll see employees, you see leaf type, whatever it is that we set up in our DB context as a data class that can be accessed, and notice leaf types is there, then we can actually access them through DB. So to get back that list after the dot, I just hold on Control and press space, and that brings back up that IntelliSense, and then I can start typing leaf types, and then I need to make it into a collection. So just by saying db.leaf types, that's literally running a select star from leaf types statement, if you're familiar with SQL. If you're not, then pretty much this is just saying, give me back all the leaf types. That's literally it. All right. But then because I need it in some form of collection, I'm going to say .to list. All right. So a list in C# is a very flexible way of getting a collection that can be used in multiple applications. You don't have to do much typecasting after that. You can just say to list, all right? But then you notice that it has a red line because it's saying it does not return a value, because it's expecting that we're returning a collection of type leaf type. So all I need to do really is just say return db leaf types dot to list. All right. And some people, I mean, everybody has a different coding pattern. Some people would have probably put it in a variable, and the var is a nice quick way of declaring a variable. So you can say var leave types, and that is equal to this, the result of this statement. So whatever gets returned from this statement gets stored inside of leave types, and then we can return leave types. So everybody does it differently. You can develop your own style, whichever one is quicker or easier for you, that's fine. But at the end of the day, as long as you understand what's happening, then that's fine. So we're getting all, and then we say var leaf types, db leaf types to list. So we're returning all of the leaf types, and then we're casting it to a C# data type called a list, which is like a glorified array. All right, so an array, you have to have a set number of objects or values. A list, it can flex, it can grow, it can contract, it can be any number at any time. So it's a very flexible collection type, like I said. So we'll just cast what is returned here to a list of leaf types, and then we just return that. So anything that is calling this function should be prepared to receive a list of leaf types. All right, and that's it. That's all we need to get all the leaf types from our database. Now, the next one that we need to implement is find by ID. So that scenario for this would be that we want to see the details of a particular leave type, right? So we see that we have sick leave, we have vacation leave, we have this, we have that. I only want to see vacation leave. Maybe there was a spelling error. Maybe there's some detail I wanted to see who created it, whatever. I click on it just to see that one record. So in that scenario, I need to find that leaf type specifically, and I'm using the ID, which is the key or primary key in the database. I'm using that to uniquely identify that particular leaf type. So the next one I'm implementing is find by ID. Now, find by ID returns a leaf type object, not a list, not a collection, but just one object, because remember, we're finding one particular one. All right. So I'm going to remove this line of code, and then I'm going to say var leave type, all right, is equal to, and then once again, I'm going to call my DB, which is my connection to the database, my database object, dot, and the table I'm dealing with is once again leaf types. And then in this situation, I really just need to find one. So I have two options here. I can say dot and say find. So they give us an actual function called find that receives as a parameter any unique identifier that should, well, anything that should uniquely identify a record in whatever table we're looking at. And then we just pass in that parameter. So we know that when we're doing it, we need to pass in that unique identifier, and then Entity Framework will do the rest and find it based on that unique identifier. And then we just return leaf type. All right, and that's it. The other way of writing this, and you'd probably see it written this way also, and I'll just comment it out, is that you could say db dot the table and let's say leaf types. And so this is how you write a comment. If you want code that is not going to, or you want to write something that's not going to interfere with the code, you just put / and that will comment out that line. So you say db dot leaf types, and then you say dot, and then you would have something, and I'll just remove this quickly so that I can get it with the IntelliSense first or default. So first or default, and then you would go into some Lambda statement, but I'm not ready for that yet. We're going to be doing that later on. So I'm not going to go into that just yet. All right, so that's another way of doing it. And I'll do it in another example when we become more seasoned with the Entity Framework syntax. So find by ID, and then we query and find one leaf type with that particular ID, which is a unique identifier. It is returned and stored inside of this variable, and then we're returning that variable. And notice that that condition is satisfied because Visual Studio knows that leaf type is being returned, and leaf type is the expected return type. Now we go on to a little bit more fun. So we go on to the create. So this is when we're creating a leaf type. So somebody fills out a form, clicks save, and then the next page refreshes with the find all data. So the grid refreshes and whatever we just added gets displayed there. So the create function needs to accept the data and actually put it in the database. All right. So for our create function, what we're going to do is we're going to say connect to the database underscore DB or object, right? And then we're going to specify the table, which is leaf types. So note that we should be receiving some variable or some object of type leaf type, and we're calling it entity. So once it hits this function, it's supposed to be receiving data in the form of entity. So db.leaf types, and then we're going to say dot add, because leaf types is really like a collection. Leaf types is literally a collection of records from the table leaf types. So we're saying that I just want to add this entity or this new leaf type to the collection of existing leaf types. So we're saying connect to the database, give me the table leaf types or all the collection of records from leaf types, and add this new one. So add and then open brace, and then you see even IntelliSense is guiding you and saying that what it's expecting is something of type leaf type, and we can call it entity. So we'll call it entity. Now, this could have been called anything, it didn't have to be called entity. It's only called entity because we defined it to be entity here. I could have called it OBJ. I could have called it puppies. It doesn't matter. The fact is that we're receiving some data type and in this specific case of leaf type, and we're just calling it entity. All right. So that's just like a variable name, an object name. And then we're basically done with that. So we say db dot leaf types dot add, and we pass in the entity. All right. So there's one more thing that needs to be done after we pass that in, and that is to save, but I'm not ready to write in the save function just yet. So I'm just going to make a comment there so I can remind myself that I need to save. And note, this is expecting a Boolean. So we're getting a red line here because one, it's not returning, and two, it's not returning the correct data value. So I'm just going to leave that comment there. We're going to come back and fix it later on. And then I'm just going to go ahead and implement another one. And the next one in line would be update. So to do an update, it is basically following the same pattern. We connect to our database, we get our table, leaf types, then we call the function, and because we're updating, they give us a function update. Now I can tell you this is a relief because back in the day, in earlier days of Entity Framework, it was not this easy. So now we can just say dot update and pass in the entity just the same. And then having made that change, we still need to save. So that's another thing that we need to save. Notice we do have a save function. I've not implemented it yet. So when we get around to implementing it, then I'll go through and clean up the rest. All right. So we did that for update, and the next one in line would be delete. So we have our read, we have our create, we have our update, and now we're doing our delete. Well, for delete, it's pretty much the same pattern as we've seen before. And what we will do is connect to our database, get our table, leaf types, and then we say dot, and this time we want to remove. All right, so it's not delete this time, but it's remove, and we're removing this entity from the collection. And once again, we need to save. So please note, you can write this line, that's fine. Something will be done, but it won't be committed to the database. This is like a commitment to the database now. This is where you say database actually run the query. All right. So now we need to figure out what needs to happen in our save. So for save, I'm going to remove this. And all that really happens in our save is that we say underscore DB, get the database, and then we say save changes. And that's literally all that needs to happen to save changes. So you could literally have put this line here. All right. So once you say DB save changes, you could put that line there. But then because of how I'm writing it, I'm expecting a bool. So if it was a void function, then it would be fine because void functions do not return values. So by making it a void function, everything would have been fine. But that's not what we have. We have a bool. So let's work with what we have. So the Boolean is expected to say, yes, a change was made. No, a change was not made. All right. So when we save changes, we need to know where change is actually made. Because if this was done, then a change is expected to be made. And just the same for every other one where I indicated that we need to actually save. All right. So when we do save changes, this will kind of return some form of integer that says if how many records would have been edited, pretty much. Right. So this says how many records are edited. So that means it should never be less than 1 in a situation like this. If you are deleting something, then at least one thing should be changed. If you're adding, at least one thing should be changed. If you're updating, at least one thing should be changed. So that means this should always return something greater than 0. So I'm going to make it into a Boolean return by saying return. And then I'm going to make this into a logical statement, all right, where I'm going to say return the value, if return the result true or false, if the value returned by this function save changes is greater than 0. So then this Boolean is now satisfied because it's going to evaluate this. Does it save changes? But I think a better way to structure it so it's less confusing though, and probably will work better, is if I just put it in a variable and say var changes is equal to underscore db dot save changes. All right. So then this is now going to store some integer for the number of changes made. And then I'm going to return after that if changes is greater than 0. So if it's greater than 0, then that's good. If it's not, then, well, obviously we have a problem, right? So we save the changes and then we return if the change is made greater than 0, meaning it should never be 0 in a situation like this. And so we can return whatever our save function gives us. So in our update function, we're now going to return save. So here's the flow. We update the entity in the database, then we hit the return and we call the save function, and the save function, which is returning a Boolean, is going to make the change and then tell us yes or no if the changes were actually saved, or sorry, save the change and then tell us if the changes were actually saved or not. And then that returns true or false. So then this update function and every other function will know true or false if it was saved. So I'm just going to take this return save function from here and put it in the delete, and notice how that red line goes away, and also in the create, and that red line also goes away. All right, so those are the changes that are required to have our CRUD operations up and running. We have our create, update, delete. We're not going to implement our get employees by leave type just yet. I'm going to leave that one blank. If you want to attempt it, then that's good. But I'll leave that one blank until we get more into our application. But right now, I'm challenging you to go ahead and repeat these steps in the other repository classes. So let's start with leave history. I want you to go through and do the create, the delete, the find all of those functions for this leave history and for leave allocation repository. Now, I actually paused the recording and I hope you paused the video and actually went through and did it, but I'm going to do it now, and I hope that you worked smartly, right? So you can copy and paste and change the essentials because the code should look pretty much the same. It's the same pattern right across the board. So this is my leave type repository, the one that we did together. I'm actually just going to copy these functions, and then I'm going to go over to my leave allocation repository and I'm going to paste. And this one is a stray. I don't need that one. So if you did that, I hope you are mindful that you don't need it. But then I have a bunch of errors because now it's saying that I'm not implementing. And that's because my data types mismatch. So I can actually do a find and replace where I'm going to just take leave allocation. Everything that is leave type, I'm just going to replace with the words leave allocation, right? So I'm going to do Control F and then use this caret here, which drops down the find and replace section. So I'm going to find leave type in this file, and I'm going to replace it with leave allocation. And then I can go one by one and replace, right? Or I can just replace all. And then after I have replaced all, then you see my errors go away and I'm done, right? So that's a nice, quick and easy way to actually just replicate the code, because once again, it's the same pattern, all right? There's another level of abstraction that we could do in the repository pattern where we actually just write this code once and we just impose which class it applies to, but I'm leaving that level out of this tutorial and just keeping it simple. So I'm going to do that again for leave history, and I'm going to just do a copy and paste, and then a nice quick way to do the replacement, I can just highlight the word and then do Control F, and it will automatically fill in whatever was highlighted. So I'm looking for, or I have it mixed up, so I'm looking for leave allocation, and I'm replacing it with leave history. And then I can just do a replace all 14 occurrences were found and replaced. And then, well, I have a slight issue here because then this is leave history's RIS, sorry, not YS. So I'll just have to manually go through and replace these. And then there I am, I'm done. So to make sure that I have no errors, what we can do is do a quick build. So you can use this, but sometimes you don't necessarily want to launch a website and so on. You just want to check for errors. You can just hold down on Control, Shift, and B. And then that initiates a build where it just goes through, checks your code, and makes sure that everything is in order and that you are error-free. And I see here that I'm having a failure, which indicates that I have a list. So you can click error list to see what the errors are, and I'm just going to go here. Okay. Oh, sorry, that was some referencing error from a previous video. All right, so I fixed that quickly. It didn't have the correct library for the iLeave repository, leave type. Anyhow, if I do a build again, and then we will see that one build succeeded, none failed. And so if I click error list, I have 0 errors. That's good. So now that we've completed the repository for leave allocation and leave history, I now need to go back to my startup and let my startup or my middleware. So this startup file represents what you call middleware or the middleware configurations. I need to let it know that there are other repositories. So I already accounted for iLeave type repository. All right, so I need to just go through, and I'm just going to Control D and duplicate those. And then I'm just going to change these out to iLeave history, and iLeave allocation. All right, and now that I've made those changes, I need to make sure that the interface and the class match. So I'm just going to make sure that I have the I version on one side on the left, and I have the corresponding class to the right. So I just did that quickly. I just did a copy and paste and remove the I and all these things. So if you want to type it out, that's fine. If you want to do it this way, that's good also. Whichever one works easier for you. Now, one of the principles behind this kind of pattern is that you don't want to put too much business logic too many places in your application. Each layer should be specific and responsible for one thing. So back in my earlier days, I used to put a lot of checks right here in the repository section of my application where I would check, is this null? Is this, is this empty? Should it should I return it or not? I stopped doing that because I just want this file to be just database related operations. All right. And then in the controller, that is where we do all of the fancy stuff. So we do our validations, we do our pre-checks, we do our post-checks in the controller, and that's where the actual logic can sit. So that's it for this video. We have successfully set up our data access layer and connected it to the database. So of course you haven't seen much action just yet, but we're doing the groundwork. And as the application grows, then we have a foundation and a template from which we can replicate what needs to be done.